Okay, so chapter 1, we're going to be doing square roots and surface area. But before we get going, actually, here. So here's what our units are going to look like. We've got square roots of perfect squares. You guys did this last year too, right? Like the word perfect square, does that make sense to people? Yeah. Okay, that's good. So if it doesn't, don't worry, we're going to go over it. And then 1.2, we're going to be going through square roots of non-perfect squares. So that would be like, what's the square root of 6? Right? That's kind of a hard one because, yeah, we'll go through why that's tough, but yeah.
It's 36.
You're thinking of 6 squared, right? We'll do that. That's good. We'll go through that though. What's that?
Isn't it 2?
No. We'll go through why it's actually a harder question than you might think. Okay, and then we got the online quiz. And then 1.3 and 1.4 are both surface area. And you guys did surface area last year. Was it the first year that you guys did surface area? Yeah. Where like you'd have to like find all the different surface areas and then add them up at the end. We're going to be doing more of that, but just harder. And again, next year in grade 10, we're going to do more of it again. Like it just keeps coming up. It's one of those things, right? Yeah, and then the doomsday test for that one. So, quick review though. We're going to go over some things that you learned last year. You might forget. That's okay. We'll go over it again. The difference between a square and the square root. Okay, so there's a bit of a language to this, right? So if I said 5 and then put a 2 right there, what's another way of saying that? That's 5 squared, right? Yeah, so that's 5 squared. And then the opposite of squaring, it's kind of in the name of the unit, right? What's the opposite of squaring something? Square root. So squares and square roots are actually just the complete opposite of each other. So let's even just do one example here. If I went 5 squared, well, here, you know what? What does 5 squared mean? Actually, someone just said it.
5 times 5.
It means 5 times 5. It means multiply by itself. Well, you guys are going to be good at this. Okay, so 5 squared really means 5 times 5. And even though we're not doing other exponents yet, what would it mean if I had 5 to the power of 3? What would that actually mean?
Cube. 5 times 5 times 5.
Right. So that's what the number up top is saying. It's saying how many times are you multiplying by itself, right? That's what it means. So we're not getting into like the cubed, or you can do any power you want, right? If I had 5 to the power of 4, well, that's 5 times 5 times 5 times 5, right? That just means that's how many times. That's our next unit. We're going to be doing exponents.
What's the mathful term for that, or whatever you want to call it?
Oh, so it's like 5 cubed. You start at some point, you start just saying 5 to the power of, right? So 5 squared and 5 cubed. This is actually kind of interesting. You guys might like this. Why do we call it squared and cubed?
Because you're...
Square's got 2 sides.
Yeah. Well, what about this? I'm kind of jumping to the chase here, but what if I had a square, and this side was 5, and this side was 5, and I said, what's the area of this thing? What would you do?
You'd square it.
Yeah, you go 5 times 5, so you'd go 5 squared. So you're literally finding the area of a square. Yeah. So, or what about this? So it goes again. So what if I said, what if I had a cube?
Whoa. Oh.
Did I just blow your mind with drawing that cube? What if I had a cube and it was 5 by 5 by 5? And I asked for, I said, what's the volume of this cube? What would you do?
5 times 5 times 5.
So you'd go 5 cubed because it's a cube. All right, so that's squared and cubed. That's where they come from, right? But anyway, once you get to like 4, then it's kind of doesn't really fit with a squared or a cubed anymore, right? Anyway, so 5 squared was, we said a few times, was 25, right? Okay, but now if I want to go backwards, but if I was given something, I said, okay, you got 25, and I wanted to get back to the 5, that's where the square root comes in. You can square something to get 25, and then you square root it would get you, what would you get if it goes 25, the square root of 25? It gets you 5, right? So that's the way of going back and forth. So squaring and square rooting is actually like the same type of thing as if I go like multiplying and dividing, right? So if I go like 5 times 4 is equal to 20, then 20 divided by 4 is equal to 5, right? You can like undo it. You can multiply it to get there, and then you can divide it by it to get back, right? They're inverse operations is like the fancy math word. So anyway, okay. That's, yeah, we pretty much went through that. So those are all considered perfect squares. Because, yeah, 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So you would say that this is a perfect square. All of these are perfect squares.
It's multiplied by itself.
Yeah, because it comes from multiplying a number by itself to get to that number, right? So, or you can take the square root of those numbers and get like a nice whole number out of it, right? All right, Pythagorean Theorem. Do you guys remember Pythagorean Theorem? Nice. A squared plus b squared is equal to c squared. I said that wrong. Okay, so what does all that mean? What happened there? Well, what that means is if I had a triangle, bad triangle, but let's say that this side was 3 and this side was 4, and I said, what is the length? I'll make that x of the hypotenuse of that triangle. Yeah.
Well, you'd have to do 3 times 3 and 4 times 4, and those two would add up to the other one.
There's one last step, but we'll write it out and I think I'll know the.
Then you have to square root.
Nice. Wow, you guys are good. All right, so what? Well, let's do it with the formula just for anyone that wasn't following that. So the formula for Pythagorean theorem is a squared plus b squared is equal to c squared. Okay, so the a and the b, what that means, like this side here, we can call that like our a side if you like. This side here, we'll call that like our b side. And then the c is always the hypotenuse. Now, the a and the b don't matter which one's which, right? I could have swapped those around either way. But the one that has to be c is the hypotenuse, okay? All right, so then if we just fill this in, our a was 3, right? That was this one. So 3 squared plus 4 squared is equal to c squared. Yeah, you're right. That'll be, yeah. So, yeah, you're jumping ahead of us. So 3 squared, is that 6? 9, right? Not 6. That's usually where people make a mistake. 3 squared is 3 times 3. That's 9.
16.
Yeah. So 9 plus 16 is equal to, and then I don't know what c is, or I could have called that x too, right? Keep it with c. Okay, so 9 plus 16 is 25 is equal to c squared. Okay, so is this 25 then? So 25.
No.
No, you gotta get square root of 5.
Right, and just looking at that doesn't make any sense, does it? If you had a triangle and one side's 3 and the other side's 4, is there any way that the hypotenuse is 25? Like that just logically doesn't make any sense, right? So yeah, there's something wrong there. And what's wrong is the very last step here. I don't want to know what c squared is. I want to know what c is, right? So the way that we like undo a squared is by square rooting. So technically, you know, we haven't done much with algebra yet, but we're going to do like a whole algebra unit. Technically, at this point, we would take the square root of both sides. And what happens there is if I square root a square, what do you think happens?
Unsquared.
It just, yeah. They cancel each other, right? That's kind of like dividing by and then, or multiplying and then dividing. It just undoes it, right? So those cancel. So we end up with the square root of 25 is just equal to c. So perfect. So square root of 25, we know how to do that. That's just 5. So c is equal to 5. Good? Okay. So yeah, you guys will have some questions like that. So, all right. Now, multiplying large numbers. Oh, I forgot to actually tell you guys too. I don't know if you know this or not. PAT, you guys have a no calculator section and a calculator section. So a lot of these things we're doing, you guys have to be able to do without a calculator, right? So that includes multiplying larger numbers like 17 times 17 and 24 times 24, right? Yeah. You know the answers? Okay.
We've had teachers tell us we're not doing PATs, and teachers tell us we are doing PATs.
I don't know what we're doing, so we'll go with we are for now, but we'll just kind of.
We'll learn for it. It could be an outbreak, we could be doing this all from home.
Yeah, I'm not sure on anything right now. So either way, if we don't do PATs, it doesn't really matter because you guys are gonna have a final exam anyway. So it doesn't really matter to you guys. Yeah. Okay. So why this is going to be important is because what if a question said, and this is a very common question for the no calculator part, it might say, what is 17 squared? Right? So I would look at that. If I had a calculator, that'd be perfect, right? I could just go 17 squared and that'd be easy, right? You could do that in like 2 seconds, right? But yeah, that's what it really means. I have to know that 17 squared really means 17 times 17. And can you guys write it down this way? Because this is typically going to be the best way to do it. Do you know what the answer is already?
Yeah.
What is it?
I did the tic tac.
It's 149 because if you go 7 squared equals 49 and 10 squared equals 100 and you just add them together.
Oh, good. You're doing like the breaking it up into the, yeah, perfect. Awesome. Okay. That's great. That's like a really good way to do it. I'm going to do the more like just systematic way. Like you guys have done this, I'm sure. But, okay. So everybody forgets every year though how to do this. So when we're going 17 times 17, what we do here, I'm going to zoom in a bit, is it's really going to be a pattern like this. We're going to go 7 times 7, right? We're going to do that one first. And then we're going to go 7 times the 10 spot, or the 1 there, right? So 7 times 1.
And you're gonna go 1 times 7 and 1 times 1.
Right, but there was one little thing that we missed there that everybody always misses. So
You have to add 0.
yeah, good. Okay. Okay. So first off, let's do this one. 7 times 7 is 49. Okay. So what do I write down?
49 of the 4 o'clock.
Yeah, I just got to put the 9 there for now, right? 9, and then the 4 goes up. Right, it goes up over to the 10th spot. Okay, and then 7 times 1. Right. So now I'm doing this one. 7 times 1 is 7. What do I do with that 4 I just put up there now? Add it, right? So what's that? So I'm at 11. So far, the number is 119. Okay, so is that it? No. Nope.
Do the exact same thing on the bottom.
Right, so now... Oh,
Times 0.
I can't see my... Here. Oh, my pen's bigger now too. Okay, yeah. So the next step is to go this one, right? Times 7 and then times the 1, right? But, like you said, the one everybody always forgets, you have to put a 0 there. Why am I putting a 0 there, by the way?
Because it fills up the 1's place.
Because it fills up the 1's place. Yeah, I'm moving over to the 10 spot now, right? Is kind of what's happening here. Yeah, so now I got to go 1 times 7, right? That one
7.
is 7. And then 1 times 1 is 1. Do I add the 4 again?
No.
No, that was from before. So just, I don't know if you want to, so you don't make the mistake, scratch it off or whatever you got to do. All right, now what? Now we got to add those numbers. Okay, so 9 plus 0 is 9. 1 plus 8, or 1 plus 7 is 8. 1 plus 1 is 2. So 289. So that's a skill you guys are going to have to get good at. You got to be able to do that one by hand. Okay? All right, I think for the sake of time, you can try 24 times 24. It's going to be the same process, though, same steps. But I think for now, just for the sake of time, I'm going to move on. All right, the new stuff. Okay, 1.1, square roots of perfect squares. So I guess it's not really new stuff. You guys did do this last year, so. Okay, so the one thing that probably will be new is we're going to do it with fractions and decimals too. But it's not so bad. We'll show you. Okay, so finding the square root of a whole number perfect square is pretty easy. So, and where this comes from, so you can see like this picture we've got here. We've got, if you counted up all the boxes, right, just added them all up, there would be 64 boxes. Or there'd be 64 boxes all the way there. And that comes because one side is 8 and the other side is 8. So like 8 times 8 would give you 64 boxes in total, right? So if you had a question where it just gave you like a square with a bunch of boxes, the square root of that thing is always going to be the length, like one of the lengths of the side, right? Did that make sense?
Yeah.
So if I had a box, let's say, well, it's just even this one. Or here, maybe I'll do a different one. Let's say we had... all right, so there's 9 boxes there. What's the square root of that? 3. And you can see because I've got 1, 2, 3, the length of that. The square root's always going to be the side of the box coming down. Okay? Okay, the other one, I know in the video you can't really see it, but you guys will see up here, I've got like a number line. here, you can use this to cheat if you like. Go ahead.
Yes.
It shows you the perfect square and the square root that goes with it, right? You guys are responsible for memorizing these. You can just memorize it if you want, or you can work it out in your head how to get there too, right? If I was, you could always just go 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81. And it'll go up to 144 typically. There might be ones where you have to go a little bigger, but up until 12 is the kind of the ones that we use all the time. It would be like a more difficult type of a question where if we would have had the square root of like, or like, yeah, 256 or something like that, right? It would be. Okay. So, example 1. Which of the following is a perfect square? 4. It is 4. You can see that from up there too, right? Square root of 4 gives us a nice 2, right? It's just 2 because 2 times 2 is 4. I can't do that with like the square root of 6, right? The square root of 6, if I was trying to think of that, that would have to be like something times something else to get me 6. Or like something times itself, I mean, to get me 6. It'd be like 2 point something or whatever, right? Yeah, 2.5. But actually, you're never going to be able to find that number. It's never going to work out just perfect. I'm kind of jumping to the chase here, but in the next lesson, it turns out that taking the square root of a non-perfect square gives you it's called an irrational number. And do you guys know how pi is like 3.14 yada yada yada, never repeats, goes on and on forever? Well, the square root of 6 and the square root of 2 and the square root of 10, those are all numbers like that. So I can't actually figure out, like, you know, what that number times itself, because I can never get there, right? Yeah, so it just never works out. So anyway, first one, square root of 4. All right, example 2. Find the perimeter of a square with an area of 81 feet squared. Okay, so 81 feet squared.
Square root.
Yeah, square root. Yeah, what would that give you?
9.
9. What part of this box would that be?
The lengths are and the width.
Right. So the square root of 81. So I'm going to go 81. So the square root of 81 is equal to 9, right? And what that did, that gave us that length of the box, right? Now, maybe just back up a bit. Do you guys remember what perimeter means?
The
Yeah,
outside.
around the outside.
You guys are awesome at this. Yeah, all the way around the outside. Perimeter is just adding up like this length plus this length plus this length plus this length, right?
So it'd be 9.
And if it's a square, then that's 9, yeah. That's 9, and that's 9. So we can get there different ways. We can go 9 plus 9 plus 9 plus 9, or what could you do? You could go 9 times 4. So what's that?
26.
Yeah.
30.
You had the right idea. You knew it. Yeah, so 36. So the perimeter would be 36. Oh, and then remember our units here? So 81 feet squared. You guys remember what that was all about? Like with the feet squared? That's just the unit for area, right? So that's when it said 81 feet squared, that means that that's what the area of our box is. So that's just the unit. Don't like square 81 or anything like that. I've seen kids do that. That's just the unit that we're dealing with. Oh, that was weird. Okay, so that's the area or the unit for that one. And now that we found the perimeter, what do you think our unit would be if we were measuring it in feet squared? Would be just feet. Yeah, just feet. So then we should write feet at the end, 36 feet. Which makes sense, right? That's like a length, just all the way around. Just add it up all the way around. And then I gave you a really easy one. Without using a calculator, find the square root of 9. 3, good. 3 times 3 is 9. So. Okay, identifying fractions that are perfect squares. Okay, so sometimes fractions actually can be perfect squares too. So let's do, for example, this one. So this one's kind of written on its side a little bit, but let's say we had 16 over 36. And I said, let's find the square root of this one.
Would you have to square root each number?
Yeah, that's actually it. So it's not near as hard as you would think. If I want to figure out the square root of this, here, I'll just do it. So the square root of 16 over 36, all I'm going to have to do is take the square root of the top and take the square root of the bottom and then just keep them in the fraction. So the square root of 16, if you need a hand, square root of 16 is 4. And square root of 36 is 6. So yeah, so that is the square root of that number. So we got a rational number out of this, so like a ratio. We probably should do something to this number though, shouldn't we? We should simplify that. 4 over 6 can be simplified, so I can divide them both, top and bottom, by 2. This should be written as 2 over 3. Okay, and going the other way, actually that's a bad example for that one. That was going to confuse you guys. Here, let's keep it as 4 over 6. I just want to show you that 4 over 6 times 4 over 6. Do you guys remember with multiplying that we just go straight across, right? So that would be 16 over 36, right? So that's just, it's like the same process with fractions as it was before. So it's just this number times this number gives you that number. What about that 2 over 3 though? This is why I was saying it was a little confusing example. So 2 over 3 is the same thing as 4 over 6. So what if I go 2 over 3 times 2 over 3? What do I get?
4 over 9.
4 over 9. What happened there?
Because 3 times 3 is 9.
Well, because it's an odd number.
Well, 4 over 9, I could have simplified this thing first if I wanted to. And that would have been 4 over 9.
Yeah.
And it would have worked out. Or even from that, I'm probably getting confusing. I feel like I'm doing a lot of things here. If I went times 4 and times 4, that would be 16 over 36. They are the same fraction, right? They're just written in a different form. Okay.
So should you divide by 2 or 4?
It actually doesn't matter. You could have like, just taken the square root of this first, right? And gotten 4 over 6 and then simplified 2 over 3. Or I could have called 16 over 36. I could have divided them both by 4 and had 4 over 9. And then that would be 2 over 3. It actually doesn't matter what order you do it in. Okay. Sorry if you kind of like lost us there. Don't worry. Okay. Oh, the picture part of this too. So if we think about this picture, right? The blue part of this, there's 16 blocks, right? And there's 36 in total. So the whole thing, like this, could be written as the fraction 16 over 36. Okay, so just looking at the picture without doing anything else, what I could have done is just actually look at the side of this thing, just like last time. That would be the same thing as 4 over 6. It's still the sides of the box, right? Even though it's a fraction.
Would it be 6 over 4 though?
Well, it's 4 over 6 because the blue part is like 4 out of the total 6. It's not just because the 4 is on top and the 6 is on the bottom. It doesn't matter how they're placed there. The blue is like the 4 of the whole 6. Okay. Now, is 4 over 18 a perfect square? How do we know?
Because 4 is an upper.
Well, let's just try it. So 4 over 18. Let's just do what we did before. So, okay, yeah, 4, I know that one. That's 2, right? Square root of 4 is 2. 18. Nope. Nope, doesn't actually work out, right? So, nope. Nope. Is 27 over 75 a perfect square?
No. I'm just saying.
Think carefully on this one.
Yeah.
Well, it's big, so I'm assuming yes. It was a
Okay.
trick question all along.
Well, sometimes when we're looking at a number like that, you can kind of like manipulate it a little bit and turn it into something that looks a bit more like what we're used to. Can I simplify this fraction to something that does look a little better?
Yeah.
What goes into 27 and 75? 3, right? So what if I divide the top and the bottom by 3? So 27 divided by 3 is
9/25.
9 over 25. That's looking better. Square root of 9 over 25? 3 over 5. So that was a perfect square, right? 3 over 5 times 3 over 5 is 9 over 25, which is the same thing as 27 over 75. All right, really tough one for the last one with the fractions. Did you? Oh, good. Okay, so simplify this expression. Okay, right now I'm dealing with square roots and I'm adding fractions. I would rather deal with this thing not having square roots, so why don't we just do the trick we just learned, right? I can change both of these. Well, maybe I can. We'll see. Square root of 4 over 9, what would that be?
2 over 3.
2 over 3, nice. So I'm going to rewrite that as 2 over 3, right? Square root of 4 is 2. Square root of 9 is 3. All right, 144. Maybe we don't. 12. Good. If you didn't get that, that's okay. Like we have to kind of like get these numbers start like into our brains slowly over time here. So you can see from up there, it kind of goes off the scale. Square root of 144 is 12. Right. So 12 over 7.
So 14
What?
over 10.
Yeah. Now what do I do?
Add them. 14 over 2.
Oh yeah, I think you're.
14 over 2.
Here, let's just go step by step. Yeah, I think you're on the right track here. But okay, so I'm now adding fractions. How do I? What do I need when I'm adding fractions again? You need a common denominator. Okay, good. So I started asking myself, okay, what numbers do 3 and 7 both go into? 21, right? That's it. So 3, yeah. So 21. So what I do is I say, okay, I know that I want this to be something over 21. Oop, I'm going to do that same color. So this is going to be something over 21 plus something over 21, right? I want to turn that 3 into a 21, and I want to turn that 7 into a 21, right? So I look back here and say, okay, with this 3, what did I have to multiply that 3 by to get that 21?
7.
Yeah, I had to multiply that by 7. So I'm going to go, okay, going to multiply that by 7.
You have to multiply the top by 7.
Also have to multiply the top by 7, right?
14 over 21.
Right, so 14 over 21. So that's 14 over 21 because that's 7 times the 2 up top. Okay, and then I look back over here and say, okay, what did I have to multiply that 7 by to get that 21? 3. So I got to multiply that by 3, so then I also multiply the top by 3.
36.
Okay, yeah, so 12 times 3 is 36. Oop. That's bothering me that it's the same or a different color. So 36. Okay,
Would you have to
We're-
make it a proper fraction?
it's actually fine just to leave it that leave it like that. Yeah. All right, so we've done all the hard work, I think.
50 over 21.
Right, so I have to I have to keep my denominator the same, right? So it's going to be over 21. And then we just actually add the tops. If this would have been subtracting, we would have subtracted the tops, but we're just adding tops. Okay, 14 plus 36? 50. And then I check to see if we can actually divide those. If there's anything that goes into 21 or 50. Nah, not 21. I think we're done. I think, yeah, I think that's all we can do. So that's good. I won't make you guys change it into a mixed fraction or anything yet. Okay, and then just really quickly, we don't have to do the decimals one so often, but we need to be kind of aware of it too. So the same way that fractions can be perfect squares, so can decimals. So is 3.24 a perfect square? Well, you're really asking yourself, is like 1.8 or is some number times itself equal to 3.24? And it is. So if you actually just take the square root of it, you end up with 1.8. So you end up with a nice number like that. And what we're looking for here, I bring it up a lot more in the second lesson, but the kinds of numbers that we might get. You guys have a calculator right now? I'll just kind of show you if you could, or your computer would be good too if you can just do. No, I mean for you guys. I want you to see it.
Oh.
Yeah. So can you guys right now take the square root, let's say of 1.44.
And one else.
1.236340731.
Oh, maybe it was a bad example. Here, let's go. Can you take the square? No, that shouldn't have been right then. Okay, so if you take the square root of 1.44, we should end up with 1.2.
I got 1.3.
1.2.
Yeah, just one. It should just be 1.2 even.
I got one.
Do you guys know square root? It should be like, you might be pushing the funny button on your computers or calculators.
And then
Well,
square
there's
root
the wrong
over
one.
x.
Yeah.
Yeah, it's 1.2.
Well, here's the problem with all your calculators. All the symbols look a little different, so I can't even tell you exactly the way it is. But yeah, sometimes it'll look like square root with a little x. Actually, that one wouldn't be. It would be square root little 2.
What is the 3?
With the square
That's a
root.
cube root.
And then what is the y?
I don't know. We'll have to.
Okay.
Yeah, I have to look at yours. Okay, so if you couldn't get that, then we'll do this. Before we get going, I'll make sure we know how to find the square root on your calculator. So yeah, you end up with 1.2. So that's a terminating number. So that just means it comes to a stop. Okay, so it just 1.2. Or if I would have gotten a number like, let's say 1.333333 that goes on forever. Another way of writing that would be like 1.3, yeah, repeating. Yep. That is also going to be considered a perfect square. Because that's like a ratio, right? Sometimes we get ratios. Like if you go like 4 divided by 3 or something like that, right? Sometimes we end up, or like 1 over 3, right? That's going to be like 0.33333333, right? Like you get a repeating number. So it's a ratio, right? So that one still works. If you end up taking the square root, and can you guys try, if you figured it out on your calculator, take the square root of like, I don't know, 1.5. What kind of number do you get?
1.224744871.
That's one of those numbers.
9152.
That's one of those numbers like pi. You're never gonna. It's never gonna repeat, and it's just gonna be like random gibberish forever. That's not a perfect square. If you end up getting one of those numbers like pi, like an irrational number,
Yeah.
then that's not a perfect square. So the calculator test is always going to work where you can just take the square root with your calculator and see what type of number you get out. So if you get a nice just number that stops, it's a perfect square. Or if you get a number that repeats, it's a perfect square. But if you get the gibberish forever, that's not a perfect square.
Oh, that's a good.
Yeah, you good with that? For the most part, that's what we'll do.
But
Yeah.
we don't get to use our calculators for that, though.
For the decimals, typically we will.
Mentally
Yeah.
find out
Or probably I think the other way to do it, which we'll get into more, is you can write it as a fraction. So let's do that for this example. You could have went 3.24 is the same thing as 324 over 100. How did I know that was over 100?
Because percent is out of 100.
Well, it's not necessarily percent. Like it never told me a percent in this case.
It's there's three numbers.
Yeah, you can think of it that way. But I still would have been over 100 if it would have been, let's say, like 23.24. It still just would have been over 100.
Because the decimal
the
only
decimal
goes to the
place.
hundreds.
Hundredths. Yeah. The names, you know how you guys have like heard the names of these like spots and decimal places like year after year? That's the 10th spot, that's the 100th spot, the next one's the 1,000th spot. That had a meaning. That's because that's the same thing, right? 3.24 is the same thing as 324 over 100. That's why it's the 100th spot, right? That's why it was called what it is, right? So you could write it like this,
If
and then
there was a 1 behind the 4, would it be 1,000?
yep, and then you'd write that as 3, 4 over 1,000 because it's in the 1,000th spot. The decimal was, sorry, I should have pointed that one. You're in the 1,000 spots. That's the same thing as that number over 1,000. Right? Yeah. So we can change it to a fraction like that and then take the square root. You might not have these ones figured out yet either, but that would be the same. Well, here we can simplify that down. So if I just 324 over 100 and then divide by 2 would get me to that, and then Again, gets me down to, divide by 2 again, gets me to 81 over 25. So then we'd have just the 81 over 25, taking the square root of that,
9 and 5.
is equal to 9 over 5. So then that might not help you out that much either, but you could probably tell if I wanted to figure out what this was as a decimal, then, well, 5 over 5 is 1. 10 over 5 is 2. So I'm probably at like 1.9-ish.
Low-key chill.
Yeah, they probably could be if they're just kind of doing like
You just do that.
Yeah, as long as I don't get overwhelmed with it. I was trying to get the numbers a little smaller, so I'm not working with it. But yeah, no, we definitely could plug kids in if they need those credits or whatever. Yeah.
There's this thing really high.
Oh, good. I was recording that phone call. And
Oopsie.
okay, that's pretty much it, guys. So,
This recording's gonna be so long.
oh, sorry, examples. So is 0.25 a perfect square?
Yeah, no, yes.
No.
Okay, so you could put it in your calculator. That would work. Let's do it the other way. 0.25. That could be written as 25 over 100. If you had 25 cents, how much money would you have?
5.
You'd have 1/4. Right? Right? 25 out of 100. You could divide the top and bottom by 25. You get 1 over 4. Right? So you get 1/4. Right? So, and then, so that's what that reduces to. And now if I'm going to take the square root of 1 over 4, the square root of 1 over 4 is, so what's the square root of 1?
1.
It's 1, right? Everyone always gets that one mixed up. Square, because 1 times 1 is 1.
So it's 1/2.
So it's 1/2, right? So it's 1 over, and the square root of 4 is,
If you have 25 cents, you actually have 50 cents?
if you took the square root of it.
Money.
Okay, so yeah, ends up being 1/2. Okay, I already kind of did one like this. So 1.25 a perfect square. Really, it's not going to simplify down to anything nice, right? You're not going to get a number, so no, it's not. Okay, I'm going to pause this.